You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. About that life on Mars. Since the early days of science fiction, Martians have been part of our folklore. Sometimes they're benevolent, often evil, but always just taken for granted as being existent. And though we've been to Mars lots of times, we've had eyes on it from the surface and from orbit, we have not yet managed to find any giant tripod monsters lumbering about on its surface. But what about the smaller life, microbial life, or at least evidence that it lives, or has lived, somewhere on Mars? Exobiologists at NASA are in unison that the answer is no. And yet every few years a news story pops up trumpeting that some scientist claims it has been found after all. Who do we believe? Today we're going to look at the evidence and at the claimants to see if we can determine whether it truly has been proven that our neighboring planet does indeed harbor life. It is a tempting claim to make. We could hardly hope for a more hospitable place for potential life than Mars. We've found organic molecules there, and we know that, at least in its distant past, Mars had lots of liquid water on its surface. As far as elements go, anything you'd need for life, you've got it on Mars. We almost have to land on life there as the null hypothesis. But we don't, because the proof isn't there. Today, we live in an era where half the population casually dismisses science and scientists as corrupt nonsense. Contempt for the scientific process brings real harm that we can observe every day. It nourishes pandemics, pours gasoline on the fires of climate change, reinforces harmful economic policy, and pulls back on the reins of modern agriculture. Not only are too many people already too distrustful of science, some actually revel in that distrust. What we don't need are reputable scientists going to the press and promoting findings that are unproven. The inevitable fallout will serve only to magnify the public distrust. When a scientist has a finding that she truly believes is correct, if she knows her business, she understands the importance of peer review and replication. The scientist most likely to be right is the one who never forgets the possibility that she's wrong. In a nutshell, it's important that scientists not promote discredited claims, and it's even more important that the media not amplify them. There will always be crackpots who operate way out on the fringe. But today we're not going to talk about Richard Hoagland and his ancient Martian megastructures, or Ron Joseph and his Martian mushrooms seeded from Venus. Today we're going to look only at legitimate, science-based claims for life having been found on Mars, and at the reasons they turned out to have not so much science behind them as some initially hoped. Start with 1976, Gil Levin and the Viking results. In 1976, the Viking 1 and Viking 2 landers both touched down on Mars and commenced scientific studies, including one called the Labeled Release Experiment. Both Viking spacecraft took up scoops of Martian soil, moistened them with a nutrient solution, then monitored the gas in the chamber for signs of metabolic byproducts. On Earth, the experiment had been tested countless times with regular Earth soil containing microbes and with sterilized soil. It had never produced a false positive or a false negative. Gil Levin, one of the original experimenters on the Labeled Release team, has been publishing for more than 40 years ever since, claiming that proof of Martian microbial life was indeed found. He and a small handful of supporters are a tiny minority among astrobiologists who don't accept his interpretation. The chemistry of Earth is not the same as the chemistry of Mars, and if we'd understood the chemistry of Martian soil before we sent the Vikings, the experiment would have been designed differently. As it is, we now know that perchlorate and hypochlorite in the soil could have accounted for the results. After the Phoenix lander discovered the soil composition in 2008, the labeled release data was reanalyzed in its proper context. The chemistry involved is far beyond the scope of this podcast, but if that's an area in which you have sufficient fluency, look up the 2018 reanalysis published in the Journal of Geophysical Research, Planets, by Guzman et al. Importantly, microbial life is not ruled out by the new results, but the fact is that the original labeled release results make sense with the chemistry of Martian soil as it's now understood. No microbial life needed. Yet, the world press often seems more interested in website clicks than in maintaining public trust. Even Scientific American has fallen victim to this in recent years, lending their respected platform to amplify blog posts by even staunch pseudoscientists promoting, in some cases, flagrantly disproven claims. As recently as 2019, Scientific American gave Levin an unchallenged platform to promote his fringe perspective as fact, tipping their hand to show that even they look at the publishing market at least as much as they look at public trust in science. 1996, David McKay and meteorite ALH 84001. In 1984, scientists in Antarctica picked up a rock laying on the ice. It was a jackpot, a fragment of a meteorite from Mars. As you may know, the rocky planets and moons in the solar system sometimes do share rocks with each other, as impacts send ejecta out into space, which then gets sucked into a planet's gravity well. Presto, a piece of Mars landing on the Earth. This one was named ALH 84001. 12 years later, NASA held a press conference to announce the amazing discovery of microfossils on the surface of the rock. Some microbes on Earth can excrete certain minerals and carbon compounds, and under the electron microscope, these can appear as characteristic globules or even worm-like shapes. David McKay was at that 1996 press conference and announced that that's exactly what these were, a position he has publicly maintained ever since. But then came the dissenting views. First, the rock had sat in Antarctica for 13,000 years, ample time for earthly microbes to leave the same deposits. In fact, the presence of Earth bacteria on the rock was soon proven, but without an obvious way to tell where any resulting microfossils had originated. At the same time, geochemists pointed out non-living processes that could have produced the same microfossil-looking structures, even on Mars. The net result is that McKay remains a loud voice in an ever-shrinking army of scientists who consider ALH 84001 proof of life on Mars. We can't rule it out, but Occam's razor simply provides us with too many alternatives. 2010, Spirit and Opportunity and the Pond Scum. In 2010, the world press exploded with headlines that cyanobacteria, aka pond scum, had been found on Mars by the Spirit and Opportunity rovers. Only a few days before, members of Opportunity's science team had revealed some recent findings at the AbSciCon Astrobiology Conference in Texas. Those findings showed that 6 years earlier, in 2004, the rover had detected the presence of sulfates, basically gypsum. On Earth, gypsum deposits often contain microfossils, the remains of ancient algae and phytoplankton. So apparently some headline writer somewhere thought that gypsum on Mars must mean microbes on Mars. Algae suggested pond scum, which suggested cyanobacteria. And so within hours, worldwide headlines trumpeted the discovery of cyanobacteria on Mars. However, this was not the right leap to make. Although some Earth gypsum does contain microfossils, the gypsum itself exists totally independent of them. The Mars sulfates did not in any way indicate cyanobacteria or any other life form. NASA's Dwayne Brown even had to tell the press, "This headline is extremely misleading. This makes it sound like we announced that we found life on Mars, and that is absolutely, positively false." 2019, William Romiser and the Mars Beetles. In 2019, entomologist William Romiser from Ohio University surprised everyone when he presented a paper at the meeting of the Entomological Society of America claiming that he'd identified a large number of Martian insects in photos taken by various Mars rovers, mostly from curiosity. Romiser had a respectable and distinguished career, so nobody was quite expecting this. His evidence? No more or less than his own interpretation of objects in the photographs. He released a poster detailing many of his findings, which is available online. His poster is not just surprising, it's actually quite alarming. It features about 20 Mars photos, but most have been zoomed in so close that hardly anything is visible except the compression artifacting. Superimposed on this, Romiser drew outlines of various beetles and other insects that he believed were shown. It's exactly the same practice we've criticized from Bigfoot believers, who take a photograph of a forested background and then cover it with circles, arrows, and outlines indicating all the Bigfoots they see hiding in it. We call these photographs blob squatches, and that term would have to apply to Romiser's Mars beetles as well. Critics, who include virtually everyone else from the entomology field and everyone from Mars science, say that Romiser's discoveries are nothing more than examples of pareidolia, a perceptual phenomenon in which we tend to perceive vague stimuli as something distinct. Although Ohio University did soon take down Romiser's press release from its website, stating that they no longer wished to engage with the media on the subject, the damage had been done. When a respected institution like Ohio University puts something forward, the public assumes it is a rigorous scientific finding. Spreading misinformation like this makes it so much harder for the public when we later have good information for them. Bad claims, especially when coming from good sources, are the science communication equivalent of crying wolf. The more bad information we allow to get out there, the further we erode the public's trust in the really important stuff like COVID-19 and human-caused global warming. Today, you can ask the average person on the street if they've ever heard that life was discovered on Mars, and if they happen to even know what that means, they're likely to remember having heard something about it on the news. The question of life on Mars is a prime example of the need for science communicators to keep up their guard, keep their eye on the importance of their mission, and get it right, or we all risk further eroding public science literacy. But we'll never erode our trust in Skeptoid's premium members like Phil Kernick, Kyle Howard, Nicholas Adolfsson, and Martin Newhouse from Ealing in London. Sustainability is a popular theme in science, and the support from these premium members is what pays the bills of our nonprofit. Please join them by becoming a member for just $5 a month at Skeptoid.com and click Go Premium. Independent science journalism needs your support or it goes away. So please come to Skeptoid.com and click Go Premium. And remember, we always do our best to publish any corrections, so if you find an error in any Skeptoid episode, come to Skeptoid.com/corrections to report it, and I'll include it in an upcoming corrections episode. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.